x squared. So a little bit more review. This was also a part of lesson 1, but it's important that we remember it for the actual lesson for today. And it's dealing with the Pythagorean identity. And our first lesson that we had together, we talked about the idea of the Pythagorean theorem, correct? Do you remember that? Or we talked about the leg squared plus the leg squared is equal to the hypotenuse squared. Well, the same thing, remember we have to use that for our trigonometry. So here is an example. We have our x value here, which is on our x-axis, and our y value here is going up and down, which is our y-axis, and it tells us that x squared plus y squared equals r squared. If we divide both sides by r squared, we get this equal to 1. So basically what they're letting us know is that cosine of an angle is equal to our x over r, and sine of theta angle is equal to our y over r. And that's something that was reviewed in chapter 1. Okay? But we need it for this lesson. All right, so that was our little review. Okay, so we know we've already talked about the trigonometric functions. We talked about SOHCAHTOA last time, correct? We talked about sine, cosine, tangent, and we talked about the fact that we can find different angles based on these 3 functions. And we didn't talk about reciprocal functions, right? So the reciprocal functions, and do you recall what a reciprocal is?
Yeah, it's it's basically like a diffraction, like flipped over.
Absolutely. Very good. So basically we have reciprocal functions of all of our 3 tangent functions. And so that makes up our 6 trigonometric functions. So we have sine, cosine, tangent, and we also have cotangent, secant, which is cotangent, which is the reciprocal of tangent. As you can see right here, 1 over tangent. Secant, which is the reciprocal of cosine, and cosecant, which is the reciprocal of sine. Okay, so it's all of the same rules except they're the reciprocal of each other. And we're going to also use the idea from the Pythagorean identity where we have the x over y, the r over x, and the r over y. So I don't have this written here, so let me write it as well. So tangent instead of equal to x over y is equal to y over x. Our cosine is equal to x over r. And our sine is equal to y over r. Okay?
Okay.
All right, so it says using trig identities, find cosine and tangent if theta is an acute angle and sine of theta equals 1 over 3. Do you think you can do this?
Find cosine and tangent. Yeah.
Okay. What would be the first thing you do?
I would find what x is because I don't have it yet.
That is perfect. Awesome.
Okay. minus 1 squared. That
Yes.
would give me, I got 8, but it doesn't go into a square perfect there.
That's
So
fine.
we
We're
would just,
yeah, we're just going to say the square root of 8. And if we wanted to reduce
okay.
this, do you know how to reduce this?
No.
Okay. So when you're dealing with squares, you're looking for a 2 of something, right? So the first thing I would do is kind of break this 8 down. So I know that 4 times 2 gives me 8. Do you agree?
Yeah.
Okay. I can take the square root of 4. We know what the square root of 4 is. What is the square root of 4?
2.
All right. So I can rewrite this in reduced form as 2 because I took the square root of that 4 and I brought it out. Square root 2. Is that okay?
Yeah.
Okay.
So you take the 2 out that you multiplied to the 4, like
No, I actually took
theoretically,
the square root of 4 out. So because I know what the square root of 4 is, I can take that out. So the square root of 4 comes out. And the square root of 4
okay.
is that 2.
Okay. Alright, yeah.
Okay. So now what is the cosine of theta?
2 square root of 2 over 3.
Very good. And what about tangent?
One over 2 square root of 2.
Perfect. Now the only thing is that I have that radical in the denominator. Do you remember how we got it out the
Yeah.
last time?
Yeah, we multiplied top and bottom by square root.
Perfect. Because it's like multiplying by 1, right? Square root of 2 over square root of 2 is equal to 1. But I can get rid of my radical in the denominator. So I get
So
root
it's
2
just
at
the
the top.
square root of 2 over 2.
Well, root 2 times root 2 is 2, right? So I have 2 times 2
Yeah.
because I already have this 2 here. So I get root 2 over 4. Is that okay?
Okay.
Okay.
Wait, so you're multiplying the 2 root 2's together because they're similar?
Well, I chose root 2 because I want to get rid of the radical. So I know that when I multiply
Yeah.
root 2 times root 2, it gives me just plain old 2. So the radical goes away. And so really what I'm doing, I'm saying root 2, so 2 times 2. And we just said 2 times, well, we know 2 times 2 is 4, and we know the square root of 4 is 2. So that's exactly what we've just done here. We just took a square and got rid of that radical. But I already had a 2 here, so I had to bring it over with it. So I couldn't forget it or leave it out. So I have to do the square root 2 times square root 2, which is 2, and then I have this 2 still here.